Dear second prep, Assalamu alaikum wa rahmatullah wa barakatuh. It's Mr. Ahmad Mahmoud with you today to introduce a new mathematics lesson. Today, inshallah, we have the first lesson in the geometry first term. Inshallah, we have unit 4, lesson 1. The lesson is called medians of the triangle. In this lesson, inshallah, we are going to know or to learn what the meaning of the median and how can we use the median to find the measures or to divide the base of the triangle. Let's start the lesson. First, we need to know what the meaning of medians of a triangle. Okay, if we have a triangle like this, the triangle formed from 6 elements, 3 sides and 3 angles, as we see, 3 sides and 3 angles. Okay, the point between the 2 sides called the vertex of the triangle. Okay, this point called the vertex of the triangle, and this line is called the base. Okay, if we point here in the middle of this side, this point is called midpoint of the base or midpoint of a side. If we connect between the vertex and the midpoint, we get a line cut the triangle. This line is called median of a triangle. So what is the median? The median is a line segment that connects between the vertex and its opposite midpoint. Again, the median is a line segment that connects between the vertex and the opposite midpoint. By looking to this definition, we have here how many vertices? We have 1, 2, 3 vertices. For that reason, I can draw 3 medians, okay, like this. I can draw another median from this vertex, connect with its opposite midpoint, and I can draw another median from this vertex to its opposite midpoint. So I have now 3 medians, okay? Any triangle included 3 medians. All the medians, by looking carefully to what happened, the medians here intersect at one point, as you see. Okay, this point we called it point of concurrence. Concurrence means intersect at one point, all collected in one point. So the medians here collected at this point or intersected at this point, which called the point of concurrence. So we have now the first theorem in this lesson. The theorem said, and we know that what the meaning of theorem. Theorem means rule. Okay, medians of triangle are concurrent. Concurrent means intersect at one point. Okay, by looking carefully to this point here, this point divide this median, the green median, into 2 parts. Part from the base and another part from the vertex. And by looking carefully, we see that the part from the base is smaller than the part from the vertex. Okay, for example, if this part equal 5 centimeters, so we find that the other part equal its double, equal 10 centimeters. Another example, if this part equal 4 centimeters, okay, this part from the base, in the base direction. Okay, by looking to the other part equal its double, which is 8 centimeters. And for example, if this part equal 4.5 centimeters, so the other part here equal its double, which is equal 9 centimeters. So I can say that by making the ratio between 5 and 10, okay, 5 and 10, okay, like this, 5 to 10, okay, divided both sides by 5, equal 5 divided by 5, 1, and 10 divided by 5 equal 2. So the ratio between them equal 1 to 2. So I can say that the point of concurrence divide the median into the ratio 1 to 2 from the base. Again, 1 to 2 from the base, or I can reverse the ratio to be 2 to 1 from the vertex, and this is the rule that we are going to use to solve the next questions. Let's solve the first question, but before solving the first question, we need to remember a remark or a rule we have studied in the first prep. Okay, if we have a triangle like this, and we have a midpoint and another midpoint, if I connect between them, this point, this line segment called mid segment. What is the mid segment? The mid segment, line segment connected between two midpoints. Okay, this point or this line segment, okay, has two properties. The first property, that this line segment parallel to the base, okay, and the length of this segment, okay, this line segment parallel to the base, and its length equal half the length of the base. For example, if this line segment equal 5, so the base of the triangle equal 10 centimeters. Again, the line segment connected between two midpoints parallel to the base, and its length equal half the length of the base. This is a very, very important rule that we are going to use inshallah in the next questions. Okay, example 1 with us. Number 1, using data given, find the following figures, find the required below each figure. Okay, number 1, we have here triangle XYZ. By looking to the triangle, okay, here we have M is a point of concurrence, because XD is a median, YF is a median, ZE is a median. Okay, this point is point of concurrence. Okay, so I can divide each median into the ratio 1 to 2 from the base, like this. Here 2 parts, and here 1 part, and because this one is a median, so this line bisect the base. Okay, so I can say that if this line segment equal 4, so XM equal its double equal 8 centimeters, and here because this line equal 10 centimeters, so we have here 5 and 5. Now he asked me about XM. XM equal double MD equal 4 centimeters, equal 8 centimeters, and YD here equal, it's clear that it is equal 5 centimeters. Number 2, we have here also another triangle ABC. By looking to this one, here I have 8, here I have 3, and the M is a point of concurrence because we have inside the triangle 2 medians. Okay, what will happen? Okay, here MA equal what? MA, first I'm going to divide the median by the ratio 1 to 2 like this. Here 2 parts as you see, and ME equal 1 part. Also MD is 1 part and MC is 2 parts. Okay, so CM equal 8 centimeters, so MD equal its half, which is equal 4 centimeters. Okay, and here ME equal 3, so AM equal its double equal 6 centimeters. So here MA equal 6 as I explained, and MD equals 4, which is 8 divided by 2 as I explained, and ME equal 1 to 3. What does it mean? Here ME, its ratio is 1, and AM, its ratio is 2. So AE, its ratio is 3. Again, ME, its ratio is 1, equal 1 part, and AM equal 2 parts, and AE equals 3 parts. So here he asked me about the ratio, ME to AE. ME equal 1 and AE equal 3, so the ratio between ME to AE equal 1 over 3, and also MC and CD. MC included 2 parts or 2x as you see, and CD included 3 parts as you see, so the ratio equal 2 over 3 like this. Okay, number 3. Here ABC triangle, M is a point of concurrence because we have 2 medians, and ED is a mid segment. Okay, Here, by looking carefully, I'm going to divide the medians, okay, from the base. Here 2 parts, and here 1 part, as you see, and here 1 part, and here 2 parts, like this. Okay, he gave me BC equal 12. BC equal 12. If BC equal 12, okay, like this, so ED equal, it's a half, equal 6 centimeters, and BE equals 9. If I have the whole median, so I'm going to divide 9 by 3, it will be 3 centimeters. So EM equals 3 centimeters and MB equals 6 centimeters. Okay, now MC equal 8 centimeters, so MD equal 4 centimeters. Again, DE equal what? DE equal half, BC equal 6 centimeters, ME equal what? Equal 9 divided by 3, which is 3 centimeters, and MC equal 8, so MD equal 4 centimeters. Another example. In this example, I have a proof. ABC triangle. Here D is a midpoint of BC. That means AD is a median, because D is a midpoint, so AD is a median, and also E is a midpoint, so BE is another median. That means M is a point of concurrence. He needs what? Okay, AD equals 6 centimeters and AB equal BE equal 9 centimeters. AB equal 9 and BE equal 9. Okay, first I'm going to divide the medians from the base like this. Here 1, and here 2, and here 1, and here 2, like this. Okay, so if I have AD equals 6 centimeters, so I'm going to divide 6 by 3. It will be here MD equal 2 and AM equal 4, and here also I have BE equal 9 centimeters. 9 divided by 3 equals 3, so EM equals 3 and MB equals 6 centimeters. Finally, because E and D are 2 midpoints, so it is equal half of 9, which is 4.5 centimeters. So first, since D and E are midpoints, this is the starting of the proof. E and D are midpoints. Okay, so AD and BE are medians. Okay, and M is a point of concurrence, and also so MD equal 1 over 3. MD equal 1 over 3 of AD, as I said, and MD equal 1 over 3 times 6 equal 2 centimeters, and after that I have ME equal 1 over 3 of EB, which is 1 over 3 times 9 equals 3 centimeters. Finally, DE equal half of AB equal 4.5 centimeters. To get the perimeter of this triangle, I will add 2 plus 3 plus 4.5 equal 9.5 centimeters. Okay, another example. Number 1. Okay, if in triangle ABC, D is a midpoint of BC, so AD is called what? If I draw the triangle like this, I have now D is a midpoint, so AD is a median in the triangle. Another one, the number of medians of the triangle equal what? Equal 3. The medians of triangle intersect. I can answer this. I intersect at one point or intersect at the point of concurrence. The point of the concurrence of medians. Divide the median into the ratio what? From the base. If he asks me from the base, it is 1 to 2. Okay, if he asks me from the vertex, it will be 2 to 1. Okay, this is a tricky question. The point of intersection of medians divides each of them with a ratio 2 to what? From the base. Okay, the ratio from the base is 1 to 2, as we know. Okay, so if he start with 2, so it will be, I will write here double of 2, okay? Double of 2, which is 4. The ratio will be 2 to 4. And this is the end of the lesson. I hope it was helpful for you. See you inshallah in the next video. Assalamu alaikum wa rahmatullah wa barakatuh.